No, periodicity.
Periodicness.
Periodicness. Periodic functions. Hey, it turns out that these trig functions are periodic.
I like that word, periodic, because it means it just keeps happening
over and over again.
On a schedule, over and over and over and over and over and over.
Like when we keep drawing this whole 0, pi, 2 pi, blah, blah, blah.
3 pi, 3 pi.
Like the fact that...
4 pi.
4 pi, okay, and we could keep going, but we're not going
5
to.
Pi?
We could.
Okay, all right.
Okay, so what happens is that sine of 0 is the same as sine of 2 pi, which is the same as sine of 4 pi, right?
Yes.
Right?
Yeah.
Like whatever.
They give you the exact same answer every time.
This direction. And so sine and cosine both have a period of 2 pi, and we'll really dive into that next section. Then tangent actually is weirder because it actually has a period of pi over 2, and we'll look at why that is.
Period of pi.
Oh, yeah, it's half of the...
It's half of the big dog. That's okay.
Okay.
Mistake number 2, all on the same day, but we won't talk about it.
So tangent of 0... Tangent of 0 is tangent of pi, which is tangent of 2 pi.
Which is tangent of 3 pi.
And if you look at, like a unit circle, which you may or may not have heard of before.
The unit circle, I love the unit circle.
If you look at what it is at 0 and then pi and then 2 pi, if you keep going around, those are the same values. Because of the fact that because tangent has the first and third quadrant that have the same sign.
Right.
Yeah.
They start to repeat a little quicker.
Yeah. So let's use this idea of periodicity to find each of the following numbers without a calculator.
Whoa, look at that. 57,801 pi over 2.
That's a lot of pi's.
Whoa.
Over 2. What if...
I mean,
What if we made this into a mixed number real quick?
Knock your socks off. Just go right ahead.
All right, so 2 with the 1 left over, 8 with the 1 left over, 9, nothing left over, 0, 1 left over. 28,900 pi's plus a half pi.
I know right where that is.
I do too.
Pi over 2.
Because
that's an even pi right there.
Even
pi is over there.
Oh, yeah, all of our even pi's are on the same side. All of our odd pi's are on this side.
It's like they're periodic.
Even pi's, and then you add a pi over 2 to that, so that means we're up here at pi over 2.
Right.
So let's think of this like the point, I don't know, 0, 1.
That is a brilliant point to choose. What made you pick that one?
Because it's so easy to use 1.
For a radius.
Yeah. So 0, 1 with
going on around here?
With a length of 1, which means that sine, which is y over r, is 1.
So, let's do another one.
Now,
can we do another?
Yeah, let's do another. We have cosine of 288.45 pi minus cosine of 0.45 pi. Okay, so here's I think what's important. Like, how far apart are these two angles?
Okay, hold on. Don't tell me. 8.
Okay, so what we could do is we could rewrite this first angle as 280.45 pi. That's the second angle plus 8 more pi's. Okay, and the reason that this is important is because if we're talking about them being 8 pi apart, these are the same values.
Get out of town.
Because 8 pi divided by 2 pi, that divides evenly. So that means that basically whatever this first angle is, we're going around the circle 4 times, and then we're back at the same spot.
I feel like this is like there's been a light that's turned on.
Yeah, just one or a lot?
Maybe more than one.
Okay, so this would give us
some
value.
Maybe they're winter holiday lights.
But we would get the same value. If we're getting the same value both times and we're subtracting, this would be 0.
You're mind blown.
Yeah, I thought so.
Wow.
I thought that would happen.
That's just crazy.
C, tangent of pi over 4 minus 99,909.
I know. I think I know right where that one is.
Okay.
I think it's going to be over. It's going to be like just the exact same thing as saying pi over 4 minus pi.
Okay, because all our even pi's are on the right side.
So all the odd pi's have to be lefties.
Left. So And it doesn't matter that it's negative really if we're just talking about pi, because we have negative, we can make all these negatives and that
Right.
still works.
It's not a problem.
So you're saying, now which way should we go for pi over 4? Like the positive direction, right?
I mean, it says positive pi over 4 there, so yes.
So yeah.
So start from there, go there, yes.
Right.
That's exactly what I would do right there,
here.
yes.
So that's a 45, 45, 90 triangle, and gives us -1, -1.
Which is 1.
2. So tangent is 1.
Jeez.
That's how you use periodicity to find trig functions.
Is it periodicity?
Incidentally, if you were to type these into the calculator, you may not get those answers. Even though 1, 0, and 1, those are like normal answers. It's not like, oh, I got this weird fraction. Like, if you try to, at least on A and C, if you try to type those in, your calculator may not actually give you the correct answer.
I don't believe it.
Well, try it yourself. I'm just saying what the book told me. The book said, hey, try it and see. You might not get the right answer. And that has to do with the fact that we're using such big numbers, I think.
And it has a rounding error.
And there is a rounding error, perhaps.
That is very interesting.
Do you know how... You know, never mind. Let's not. Never mind. Never mind.
Okay, good talk.
Yeah. Bye.